Hi, I'm Sydney Huber.
I'm Noah.
I'm Gabby Muncie.
And I'm Jess Strouch.
And our topic is the olfactory bulbs.
Before we tell you all about the olfactory bulb and how it affects our sense of smell, I want you all to close your eyes and relax.
Now picture a food, your favorite food, or a certain place or person with a very distinct smell. Remember that smell and think about how much you love it and cherish it. Now imagine never being able to smell that scent again. Imagine never smelling freshly baked cookies or your grandmother's cologne. This is called anosmia, which is the inability to smell.
So I'm sure that when you were a kid, you were taught that there are 5 major senses, which are sight, hearing, touch, taste, and smell. I'm sure you may have also wondered what it might be like to be missing one of these senses. Well, there was a study done by a Harvard medical publishing doctor by the name of Dr. Schmerling that found that most people would agree that your sense of smell is the least important out of all 5 of the senses. And while not being able to smell may not be as bad as not being able to see or not being able to hear, not having your sense of smell can have effects and repercussions in an individual's everyday life.
After watching how important our sense of smell is, let's learn about what gives us the ability to smell. So, what are the olfactory bulbs? The olfactory bulbs are a neural structure that receives and processes information from the sensory neurons and relays these signals to different parts of the brain, such as the amygdala and the limbic system. The olfactory receptor axons extend into the highly organized olfactory bulbs, where odors are sent and processed. In order to understand how smell works, we have to understand how neurotransmitters work. Dendrites have tiny synapses that receive information from other neurons and transmit electrical signals to the soma, also known as the cell body. This signal is then fired to the axon once the signal exceeds the action potential. The axon then transmits the neural signal to other neurons or cells through the use of synapses. Right where the end of the axon meets the beginning of a new dendrite is called the synaptic cleft. Neurotransmitters held in vesicles in the axon terminal are released to bind to the receptors in the dendrite. We can think of the olfactory bulbs almost like a dendrite because they receive various odor molecules through receptors and process the scent.
Welcome to 2-Minute Neuroscience, where I explain neuroscience topics in 2 minutes or less. In this installment, I will discuss the olfactory nerve. The olfactory nerve is a sensory nerve responsible for transmitting information about olfaction, or smell, to the brain. The nerve begins in the olfactory epithelium, a specialized collection of cells that lines the nasal cavity in humans. The olfactory epithelium contains millions of olfactory receptor cells. The axons of the olfactory receptor cells form bundles called phyla that travel up through a structure called the cribriform plate, which is part of the bone called the ethmoid bone that separates the nasal cavity from the brain. The cribriform plate has holes that allow the phyla to pass through it. The phyla make up the olfactory nerve. The olfactory nerve travels to an adjacent structure called the olfactory bulb, where it forms synaptic connections with several types of olfactory bulb neurons, like cells called mitral cells. These olfactory bulb neurons carry information about smell to the olfactory cortex as part of the olfactory tract.
Let's take a quick look into a normal brain. Everything looks good here. The olfactory bulbs are present and working. Oh no, they're gone.
Oh no, I can't smell anymore.
As you can see from this diagram, the odors are still coming in through the nose and attached to the olfactory epithelium. But because the olfactory bulbs are absent, there is nowhere for the olfactory epithelium to relay these molecules to become processed. So simply nothing happens and smelling does not occur. Now we are going to analyze the differences between the brains of a normal person and a person who is missing the olfactory bulbs. Here, the olfactory epithelium is able to relay molecules from a specific odor to the olfactory bulb, where they will be sent to the limbic system and processed. Here we can see that there are no olfactory bulbs. This means that the olfactory epithelium don't have anywhere to relay the molecules from specific odors to be processed. As we already know, anosmia is the inability to smell. But what causes anosmia? Well, there are many different factors, such as old age, head trauma, strokes, damage to the olfactory bulbs or the olfactory epithelium, and last but not least, colds or a common flu. Although losing your sense of smell doesn't seem like it would have that big of an impact on your life, it does in fact make simple tasks a lot more challenging. For example, eating. Since olfaction and taste are related, it makes it a lot harder to eat because taste isn't really a thing. Also, in terms of changing a baby's diaper and knowing when to, it's very challenging when you can't smell. You walk upstairs to get changed for an event, and you leave your stove on downstairs. A piece of paper gets caught in the burner and sets your house on fire. Now, a normal person would be able to smell this fire and immediately call 911, but a person with anosmia can't do so.
I think your baby's diaper needs a change. It stinks in here.
What do you mean? I don't smell anything.
I think you need to change your baby's diaper.
The inability to smell can also put you in some dangerous situations, such as not being able to smell when the fire is going on and not being able to smell a gas leak.
Okay, so I'm gonna ask you to close your eyes and plug your nose, and I'm gonna feed you something, and then you're gonna tell me if you can figure out what it is. Okay, open your mouth.
I can't taste anything.
Okay, unplug your nose.
Like peanut butter.
It's a Ritz cracker.
Mm-hmm. I couldn't taste anything.
Okay, so I'm gonna give you a piece of food, and you're gonna close your eyes and plug your nose, and you're gonna try to describe how it tastes without smelling it. Okay. Okay, so close your eyes. Open your mouth. You gotta be able to put it in your mouth.
Oh, I don't like these. It took longer though. It did take longer to taste.
Okay, so I'm gonna give you a piece of food, and you're
Good.
gonna close your eyes
Great.
and plug your nose, and so you're not gonna use your sense of smell when you're eating it.
Cool.
And then you're gonna tell me how it's different than regular.
Okay.
Okay, close your eyes, plug your nose, open your mouth.
Oh, it's like salty. Is it like a Ritz cracker?
More than just that. What else?
Is there peanut butter in there?
Yes.
Yes. How did it taste different than usual?
It was a lot saltier, and I couldn't even taste the peanut butter until I like felt its texture.
You can unplug your nose now if you want.
Oh, it smells. It tastes so much different when you unplug your nose.
Signals from the taste buds and signals from the nerves in the nose can be used to communicate sensations to the brain. This information is then integrated in the brain to create a flavor that the brain can then recognize.
Study of the day, Olivia. She was a healthy 35-year-old woman. Until one spring day when she got into a bad bike accident and suffered serious head trauma. The doctors patched her up, but after a couple of days in the hospital, she noticed something strange was happening. Or rather, something wasn't happening. She could no longer smell. Not the flowers in her room, not the nurse's rubber gloves, not even the horrible hospital food. In the weeks that followed, she blackened a batch of cookies because she couldn't smell them burning. She couldn't smell the lilacs blooming or her husband's aftershave or her car overheating. She drank expired milk because she couldn't taste that it had gone sour. The world got a lot less interesting. Eating wasn't very exciting, and Olivia started getting depressed. Life felt sterile and unfamiliar. Olivia had anosmia, a partial or complete loss of the sense of smell, and with it, most of her ability to taste. This unfortunate condition is caused by things as diverse as head trauma, respiratory infections, even plain old aging. Alright, I'm about to perform a superhuman feat and sit here with this amazing slice of Hawaiian pizza without eating it. so that I can describe it to you how we smell things. So if it sounds like I'm going fast during this episode, it's not that I don't enjoy our time together, I just want to get to the part where I actually get to eat the pizza. Now the process starts as I sniff molecules up into my nose. This means that for you to be able to smell something, the odorant must be volatile or in a gaseous state to get sucked up into your nostrils. And yes, that means when you smell poop, there are actually poo particles up in your nose. The harder and deeper you sniff, the more molecules you vacuum up and the more you can smell it. Most of these molecules are filtered out on the way up your nasal cavity as they get caught by your protective nose hairs, but a few make it all the way to the back of the nose and hit your olfactory epithelium. This is your olfactory system's main organ, a small yellowish patch of tissue on the roof of the nasal cavity. The olfactory epithelium contains millions of bowling pin-shaped olfactory sensory neurons surrounded by insulating columnar supporting cells. So these airborne pizza molecules, many of which are just broken off parts of fats and proteins, land on your olfactory epithelium and dissolve in the mucus that coats it. Once in the mucus, they're able to bind to receptors on your olfactory sensory neurons, which, assuming they hit their necessary threshold, fire action potentials up their long axons and through your ethmoid bone into the olfactory bulb in the brain. But here's the wonder of specialization for you. Each olfactory neuron has receptors for just one kind of smell. And any given odorant, like this pizza, is made up of hundreds of different chemicals that you could smell, like the thymol of the oregano and the butyric acid of the cheese and the acetylpyrazine of the crust. So after each smell-specific neuron is triggered, the signal travels down its axon where it converges with other cells in a structure called a glomerulus. This takes its name from the Latin word glomus, meaning ball of yarn, which is what it looks like. A tangle of fibers that serves as a kind of transfer station where the nose information turns into brain information. Inside the glomerulus, the olfactory axons meet up with the dendrites of another kind of nerve cell called a mitral cell, which relays the signal to the brain. So for each mitral cell, there are any number of olfactory axons synapsing with it, each representing and identifying a single volatile chemical. As a result, every combination of an olfactory neuron and a mitral cell is like a single note, and the smell coming off of this pizza triggers countless of those combinations, forming a delicious musical chord of smells. Now just imagine a piano with thousands of keys able to produce millions of unique chords, and you'll get an idea of how amazing our noses are. Scientists estimate that our 40 million different olfactory receptor neurons help us identify about 10,000 different smells, maybe even more. So once a mitral cell picks up its signal from an olfactory neuron, it sends it along the olfactory tract to the olfactory cortex of the brain. From there, the pizza smell hits the brain through two avenues. One brings the data to the frontal lobe where they can be consciously identified, like, oh, melted mozzarella, while the other pathway heads straight for your emotional ground control, the hypothalamus, amygdala, and other parts of the limbic system. This emotional pathway is fast, intense, and quick to trigger memories. If the odor is associated with danger, like the smell of smoke, it quickly activates your sympathetic system's fight or flight response. That's a big reason that Olivia's anosmia was so problematic. Without being able to smell, she couldn't access emotional memories wrapped up in particular scents or sniff out dangers in her environment. And these same intellectual and emotional dynamics apply to taste as well, because after all, taste is 80% smell. As you chew your food, air is forced up your nasal passages, so your olfactory receptor cells are registering information at the same time as your taste receptors are, so you're both smelling and tasting simultaneously. So it's true that if you have a bad cold or if you just hold your nose, your sense of taste is impaired, but it's not like you can't taste anything, it's just that more subtle flavors involve more volatile compounds that are picked up by your olfactory receptors. So you can hold your nose and taste that something is sweet, but you wouldn't be able to pinpoint it as being caramelized sugar. Likewise, you can taste that something is generally sour, but you can't tell the difference between a lemon and a lime.
Sydney Huber's going to start by sharing her story with anosmia and how it has affected her life.
We decided to research the olfactory bulbs because I am directly affected by anosmia. I was diagnosed my junior year of high school with anosmia when an MRI showed that my olfactory bulbs were actually missing from my brain. So I have actually never been able to smell my entire life, and it's crazy to think that I just figured this out my junior year of high school. This is an MRI of a person whose olfactory bulbs are normal size and they're able to smell. Now these are my olfactory bulbs. As you can see, they're too small or they're not present. Further investigation was requested, but we decided not to do it because I cannot smell regardless.
Next question is, what is anosmia? What are some of the hazards that come with anosmia? How is one diagnosed with anosmia? How are smell and taste related to each other? Name a specific example that shows the connection between smell and taste. Next time you're sitting around a meal with freshly baked bread and amazing steak, just think about what your life would be like if you couldn't smell those things. How would your life be different?
Many people do not know what anosmia is. We hope our lesson today helped you understand what anosmia is and how it affects a person's everyday life.
Thanks for watching. The next question is, what is insomnia? That's not the right word.